Hello, Algebra 2. Here we are with your 5A summative review. Writing the polynomial function in standard form, so make sure we have f of x equals at the end, given the roots. Okay, so if we have x equals 2, we're going to have x minus 2, because from factored form, this answer made something equal 0. So that's going to be x minus 2. Now here comes the tricky parts. Okay? If we have negative 3 minus I, you also have negative 3 plus I. Okay? Now, two ways to get what the parentheses are for each of these. What's really happening is you're going to have x minus whatever the answer is. So we would really have x minus negative 3 minus I. And if you distribute that minus, it becomes x plus 3 plus I. So it just turns that to be opposites of everything that was there. So that one was opposite, that one's opposite. We could do the same thing and get opposite, opposite. So it would be plus 3 again with a minus I. So if we had x minus negative 3 plus I, minus goes in, and we'll have x plus 3 minus I. Okay? So if you want to do it that way, or if you can just remember x and then opposite of each part. So x plus 3 minus I, and x plus 3 plus I. Now the fun part. We're going to take each one of these times each one of those. So we're going to have 9 pieces. So we're going to have x to all 3 of those. So x times x is x squared, 3x plus ix. And that was just taking this one to all 3 of those. Next, we take the plus 3 to all 3 of those. Plus 3x plus 9 plus 3i. And then we take the negative I to all 3 of those. Negative ix, negative 3i, and negative I times I will have negative I squared. Okay, now there's 9 parts there. The nice part about that, though, is anything with an I should cancel or simplify. So plus ix has a minus ix partner. Those should cancel. Plus 3i minus 3i should also cancel. Minus I squared. Remember, I squared comes from I comes from the square root of negative 1. So I squared is negative 1. We have minus negative 1. That's actually going to be a plus 1. So I'm going to write plus 1 here and cross that out. So simplifying this down, we have x squared plus 3x is going to be plus 6x. Plus 9 plus 1 is going to be plus 10. And then we have our x minus 2. And now we get to do it all over again. But it's a little bit shorter. This time it's only 2 times 3 things, so there should be 6 pieces instead of 9. Okay, x times x squared is going to be x to the third plus 6x squared plus 10x. And now we take the minus or negative 2 to all 3 things. Minus 2x squared minus 12x minus 20. So we'll have x to the third plus 4x squared, 10x and negative 12x of minus 2x, minus 20. And don't forget to write f of x equals on the answer line. We did it. We made it all the way. Next type of problem, graphing and labeling. Okay, we're going to be labeling the maximum, minimum, y-intercept, zeros, rounding to 2 decimals if we need to. Okay, I'm going to do this one. Alright, so step 1, we're going into y equals. Okay, you might have to clear something out. Okay, clear. Negative, not minus, negative 2. Okay, the difference between that's minus, that's negative. Negative 2 x to the third, okay, power key. Third power, bump it over, plus 5x squared, no regular x's, minus 3. We graph. Okay, first thing up is relative maximum. There's the top of a mountain. Remember, it's possible to have more than one relative max and more than one relative minimum. Those just mean every top of the mountain and bottom of the hill. So, maximum, second, trace, maximum. Okay, we're going to scoot our little cursor up to the top of the hill. Okay, we got left bound and right bound. Always starts with left bound first. So get up to the top of the hill and we're going to hit left like 3 times. Left, left, left. And hit enter. Back up to the top of the hill. Now right bound 3 times. Right, right, right. Enter. And you can see that we're kind of like fencing that in. And we want to go guess back on the top. And we got 1.67, comma 1.63. So we write it down here, and we do the best we can up here. 1.67, 1.63. Okay. Minimum. Same thing. Second trace, minimum. Now we want the lowest one. So all the way down to the bottom of the hill. Left bound, left, left, left. Enter. Bottom of the hill, right, right, right. Enter. Bottom of the hill again. Enter a third time. And look at that. It's going to be 0, negative 3, which is also the y-intercept. 0, negative 3. Okay, which is also our y-intercept. Now, let's say that didn't happen. How would you be able to find the y-intercept? Okay, so finding the y-intercept from the graph, you should be able to push trace, 0, enter, 0, negative 3. It should also be the last number without an x at the end. Okay? Zeros or roots are where we cross the x-axis. Looks like we got 3 of them. Okay? Second, trace, 0. Alright? So, these jump pretty quickly, so we might not get as perfect as we'd like. Okay, so we're going to get as close as we can. And then always left bound first. Left, left, left. Enter. Back down to the 0 spot. Right, right, right. Enter. Back to the 0 spot. Enter a third time. Negative 0.69, comma 0. Alright, there's one of them. Okay, we do it again. Second trace, 0. Okay, get as close as we can. Left bound is always first. Left, left, left. Enter. Back to the 0. Right, right, right. Enter. Back to the 0. A perfect 1, 0. Alright. Why don't you push pause quick and get that third one on your own. Alright, let's see if you were able to get that third one on your own. Second trace, 0. Scooch on over. Left bound is always first. Left, left, left. Back down to the 0 spot. Right, right, right. Back to the 0 spot for the third and final time. 2.19. Oh, good, we got one of these. If you get a 1e or something e to the negative, that's 1 times 10 to the negative 12th. That's going to be 0.0000000000001. It's basically 0. Okay, it's 0. So we got 2.19, 0. Okay, now Mr. Handke likes to go through and get some nice points. Alright, so just starting over there on the left, what if I did negative 2, enter? Ooh, negative 2, 33, way up there. Negative 1, enter. Negative 1, 4. So that could be helpful for our graph. 1, 2, 3, 4. 0, we already got that one. 1, enter. 1, 0, we already had that one. 2, enter. 2, 1, that's going to be helpful. 3, negative 12, already off the graph. Okay? So now we're going to go through and smooth this out. It's pretty steep on the ends. Okay? And there we go. Now talking about domain and range. Domain, it's going to go left and right forever, so we're going to have all real numbers there. Range, up forever, down forever, also all real numbers. Okay, I would maybe expect a 2x or an x to the 4th problem, like over here on the left, on the test, because then you at least have to think about the range. And you're going to have y's are greater than or equal to, or y's are less than or equal to. All right, graphing these square roots. Remember, insides are opposite, outsides are the same. So this is going to be 2 to the right and 3 up. 1, 2, 1, 2, 3. And we definitely have a start point, and I think it's good to label that start point. That because our domain and range is going to be based off that start point. Okay? We have a negative multiplier, so we're just going to flip our points pattern. So normally we go over 1, the square root of 1 is 1. So normally we'd go up 1, we're going to go down 1 because of that negative multiplier. Next one would be out 1, 2, 3, 4. 1, 2, 3, 4. The square root of 4 is 2. So normally we'd go up 2. We're going to go down 2. Okay, so that's the minimum amount of dots you need, the start point plus 2 more. If you could fit out 9, up 3, or in this case down 3, you could do that as well. Okay, this is not going to have 2 arrows on it. It's going out from here. And there it is. Domain. Okay, these are all going to be related to the start. X's are greater than or equal to 2. Range, my y is less than or equal to 3 because we're going down. So it's less than or equal to that y coordinate. Alright. Then we have our very tough one. Okay? Remember that when we have a multiplier in the inside, we have to set this equal to 0. 3x plus 1 equals 0. Subtract the 1. and divide by 3. So the x-coordinate of our vertex is going to be negative 1/3, not the vertex, start point, and our y-coordinate is still this 5, negative 1/3, comma 5. 1, 2, 3, 4, 5. Okay, now the complicated stuff happens. Okay, our normal points pattern is 1, 1, 4, 2, 9, 3. The outside multiplier goes to all the y's. So we're going to go negative 1/2 to all of those. The inside multiplier goes to all the x's, and we do the opposites. We're going to be dividing those by 3. Okay? So this one becomes 1/3 over, down 1/2. So we're going to go 1/3 over, which puts me back on the 0 line, down 1/2. Okay? Now we're going to go over 4/3, down 1. Okay, negative 1/2 times 2 is going to be negative 1. 4/3 is also not bad because we're going to go 1/3, 2/3, 3/3, 4/3 is over here on 1, down 1. So, I mean, technically there's your start point plus 2 more. Let's get another one in there. 9/3 is going to be over 3. And negative 3/2 down 1.5. So over 3. 1, 2, 3. Down 1.5. Alright, there it goes. If you want to label those points, that would be 0, comma 4.5. That's going to be a nice 1, comma 4. And in this one, we're at 1, 2 2/2, comma 3.5. Okay. Domain, we're going to the right, so x's are greater than or equal to negative 1/3. Range, our y's are going down again, less than or equal to 5. Last problem. Square root of x has been reflected vertically, translated down 1 unit, and left 2. And we need it in f of x equals format. Okay? So, reflected vertically, we're going to have a negative on the outside. Down 1 unit, up and down, is normal, and that's on the outside. So we're going to have minus 1 on the outside. Left 2 units. Left and right is on the inside, and opposite of what your brain wants to do. So left is negative, which makes you want to do minus, but it's actually going to be plus. And there it is. Okay, you just kind of think in reverse. We're used to seeing this and thinking what that is. Now you're getting told this and having to think in reverse and write it down. Alright, thanks for watching, crew. Best of luck on your test review and test.